Hey guys, my name is Nico and I'm the CTO of Arcium. And today I'm going to be telling you guys a little bit more about building dark pools and how Arcium can be helpful for this. But before we talk about dark pools, or otherwise known as encrypted order books, let's quickly talk about the traditional variant, which is normal or sometimes called lit order books. So here we have an example of one. At the end of the day, an order book is just a way so that we can organize a market where people want to trade one asset for another. So in this case, let's say this is a market for SOL USDC, where people want to buy and sell SOL in exchange for USDC. If we look at this here, inside of our order book, we have two sections here. We have one-time people willing to sell SOL and people willing to buy SOL for USDC. And if we look at the sell orders here, or if we look at any order, the structure is pretty uniform. We have a price, we have a quantity, and we have a name of the person who submitted that order. So if we look here, we can see Nico is willing to buy 10 SOL when the price hits 201. And if we look here, on the buy side, Lucas is willing to buy 30 SOL when the price hits 200, or drops to 200 rather. And so whenever you have a matching order sort of in the middle here, that order gets executed and the trade happens because you found the seller and a buyer willing to exchange their SOL for USDC at the same price. And, at first glance, this looks like it's very good. Everyone's happy. People can submit their orders. People can take orders, and trading happens. But if we look a little bit more closely, there is some issues with this. The first one arises from, if we look at this order book a little bit closer, we see something stands out. So most orders are like 10, 15, or 30, 40, whatever. So small amounts of SOL, relatively speaking, except for Alice. Alice is going to sell 100,000 SOL once the price hits 204. Now, if I'm an outside observer of this order book, or if I'm even on the buy side at the moment, I will look at this and I will say, should I really be buying SOL right now? Because even if, right now I might think that $201 is a really good price and I would be willing to take Nico's order here, I might reconsider just because I know the second the price hits 204, there's basically going to be huge sell pressure from the side of Alice, which will most likely make the price drop. In some cases, probably even lower than what I initially bought it for, considering how little quantity is being traded in regards to that. So this in turn, in one hand, disincentivizes external viewers who might want to take these orders. And on the other side, might even disincentivize people who are already on the buy side. For example, Lucas might look at this and say, let me retract my buy order for a little bit later, once Alice's order has been processed by the order book. Otherwise, I might risk, my nice buy at 200 actually not working out in my favor when Alice's order goes through and drops the price down to 190 or maybe even lower. The second problem that we have with this is one that especially those of you interested in blockchains will be very familiar with, which is MEV in the form of, front running, back running, sandwiching, and all that. Where the main problem basically is that if Lucas's order is about to be actually executed, and this is visible in the mempool or to validators in some other manner before it actually gets executed for the blockchain, essentially the validators, or sometimes other people called searchers, can see this ahead of time. And since they can see, okay, Lucas is about to buy 30 SOL at $200, that means I can sneak in a buy order that's smaller ahead of time. Lucas's buy order is going to pump the price up, and then as soon as Lucas's buy order has passed, I can instantly sell my SOL again, giving me a little profit, a guaranteed one. But on the flip side, also causing the price to drop for Lucas, even though he didn't even do anything in particular to cause that. And the final problem that we have is copy trading, which I think is pretty straightforward. Let's say you're Tolly, and you have some super successful trading strategy that works very well. And I'm an external observer, and I see that, oh wait, Tolly has just submitted a buy order at 198. Let me do the same thing, since I know that Tolly is a very successful trader. This might be, quite an issue or annoying for Tolly, just because let's say he spent a lot of money developing his trading strategy, so he might not necessarily want, a bunch of freeloaders copying his strategy without offering him anything in return. And in the worst case, it might even cause downside for Tolly if his strategy, suffers from being employed at a larger size than he initially predicted it to be. So if we summarize this again, the main issues that we have are order book fading. So this is, this thing with the large orders, MEV, and finally copy trading. And basically all of them stem from all the values in our order book being visible to everyone. So upon first consideration, the way to solve this seems quite simple, right? We just have to make sure that all these values are hidden. The problem is though, how do we do that? And if we can take a quick side lane, we can see that in traditional markets, this is already a problem that many people have thought about. So in traditional markets, dark pools or encrypted order books process on any given day around 30% of total equity spot volume. So this is something that people are definitely very interested in using. But how do they work there? So the way they work is basically just that we say, we have our sellers or our sell orders, which, even though I'm clustering them together here, they aren't visible to each other. And we have our buy orders, let's draw them over here. And again, same thing here, even though I'm drawing them together, they're not actually visible to each other. And then we have some third party that, is trusted to some extent to not leak this data to other people, that stands in the middle, receives orders from each side without, leaking them to other people, and then basically takes care of matching them internally using some matching algorithm, and basically allows everyone to trade with each other without them leaking their orders or any information about them to each other. In theory, this would work great, but in practice, it has some issues once again. And the issue is that we have a trusted third party in the first place. Because if we think back to our example, the people who are most likely to use such large order books are either sophisticated traders who don't want to suffer from copy trading, or on the flip side, people who have very large size who don't want their order to weigh on the order book. And so if we have a trusted third party that has access to tons of very large orders, even if they're not supposed to peek at the encrypted data, they still might. Because when you have very large orders, even a small movement or a small advantage that you can gain from that generally scales with the size of the order. So for this reason, over the last decade, dark pool operators in traditional finance have had to pay over $300 million in fines just because of alleged infringement of looking at order book data. So for this reason, we think that using Arcium, you can perfect this, at the moment, somewhat flawed system. And the way to do this is quite simple. Just remove this central party who has, theoretically can look at orders, and you replace it with Arcium. And since Arcium is just a network that allows you to run MPC computations, which allow you to compute directly on encrypted data without it being visible to anyone directly, if we replace it with Arcium, we can still do all the same order book matching and order book insertion and anything else that we might want without anyone being able to see anyone's order. And most importantly, without Arcium ever having the chance to potentially look at orders, even if they would want to, since it's not any given entity, but rather, a network of nodes that operate on solid cryptography and not on, trust. So for this reason, we think with Arcium, you can enable anyone to trade anything encrypted without revealing anything about the data. So yeah, that was basically dark pools and why we think Arcium is cool. It's very cool for using them. If you're interested in learning more about Arcium, make sure to check out our docs at docs.arcium.com. And we have some more resources linked down in the description as well if you're interested in dark pools in particular. Thank you.